Okay, good afternoon. Still we are in dynamics, kinematics of particle, particularly on the curvilinear motion. As I have discussed with you in the first part of this curvilinear motion, there are three methods we are using. First, we have the rectangular components, the normal and tangential components, and the radial and transverse components. I have already discussed with you rectangular components, and today I'm going to discuss normal and tangential components. As for the radial and transverse components, due to time, I'm going to discuss with you radial and transverse components. So for tangential and normal components, let's refresh first ourselves regarding the terms. Tangent. When we say tangent is or tangential component, it is a component that intersects a curve on a single point. So let's say we have a curve here. If we're going to draw a line that passes through the point of tangency, that is your tangent line. As for the normal line, that is a normal component, that is a component where it is perpendicular to the curve and points to the center of curvature. So that is my normal line. Again, you have to take note when we say normal line, it is always perpendicular to your tangent line. Okay? Reviewin lang natin kung ano yung napag-aralan natin sa may rectangular components para makita natin kung ano ba ang pagkakaiba ng rectangular dun sa may tangential and normal components. So for rectangular components, let's say for this curve, we have here the particle and it travels along the curve. So as we have learned in the rectangular components, this particle has two components. We have the component along the x-axis and along the y-axis. And pag na yung namang component nandun sa side na yan, meron din siyang x and y components. As dito rin, meron din siyang x and y components. So if this is your y-axis, if you try to observe the components of the particles along the curved path, mapapansin ninyo yung y component nung velocity nung particle, it is parallel doon sa may y-axis. The same with kung yan yung x-axis ninyo, the x component of your velocity is also parallel to your x-axis. So, yan yung napag-aralan natin doon sa may rectangular component. Now, how about tangential and normal components? Let's say, yung nakikita ninyong small circles na kulay blue sa inyong screen. Let's say that is the center of curvature ng inyong mga curve. So, kung idodrawing ko ulit yung aking mga points, yung mga tangent lines and normal lines na nakikita ninyo. See, yung tangent line and yung mga tangent lines ng bawat points kung saan yung particle, nag-intersect sila. If you try to compare doon dito sa may rectangular components, hindi mag-i-intersect yung mga y components. Right? Pero dito sa may tangential and normal components, as you can see here, nag-i-intersect yung mga normal lines. And their point of intersection, yun yung mismong center ng curvature. See, that is the difference of rectangular and tangential and normal components. Pagdating sa may, kung paano mag-travel yung particle dun sa may curved path. As for the equations, yan yung kumbaga summary ng pagkakaiba ng normal and rectangular component. Pagdating naman sa may equations, di ba sa rectangular components, wherein s, that is the distance, meron tayong x and y component. Ulitin ko ulit, you do not be confused with the I and j. Those are just your components. And we have, dun naman sa may tangential and normal component, the same din, yung s, that is the function of s, kung ano man yung given dun sa sum problem. And velocity, dun sa may rectangular components, you have your x and y component for the velocity. And we also know, na pag-aralan din natin sa may rectangular component, velocity is the derivative of your s or your distance with respect to time, or v is equal to ds over dt. The same in tangential and normal components, v or velocity is equal to ds over dt, wherein your s, naging function of s over dt. Baka may magtanong ulit, ano yung u? Para saan yung u na yan? Yung u dito, para din siyang dun sa may dito sa may rectangular component, yung I and j. Diba sabi natin yung I and j, it pertains to the component. Kapag I, it pertains to your x component. Yung j, it pertains to your y component. The same with this one. Yung u dito, it is a vector component. This is a vector component. And at the same time, we can also name this as your tangential velocity. Paano naging tangential velocity yan? Bakit wala bang normal ang velocity pagdating dito sa tangential? Let's try to go back to my illustration dito. If you try to look at this diagram, dito sa may rectangular component, itong dalawang ito, yung x and y component na yan, di ba yung kanyang resultant ay yan? Which is the velocity. Tama. Yung resultant na velocity na yan, kung mapapansin ninyo, the same naman siya dun sa may normal and tangential component. Okay. Ulit, tingnan natin ulit ito. Itong dalawang components na to, yung kanyang resultant, yan. Pag titingnan ko sa may normal and tangential component, yung resultant na ito, the same siya doon. Right? The same with this. Itong dalawang components na to, ang kanyang resultant ay yan. Pag titingnan ko sa may normal and tangential component, the same siya doon. So, from this illustration, walang normal velocity dito sa may normal and tangential component. Kasi kita naman sa diagram, yung velocity dito sa may rectangular component ay eksaktong siya rin yung velocity doon sa may tangential component. So from that, we can say that yung u dito is the vector component. It is also the tangential velocity kasi walang normal velocity and there's sa may tangential and normal components. Kayo man nga maulaw niya. As I've said during dun sa may yung mga pumunta dito sa school, do not be confused with the letters you can see here in the board. Again, itong u na to, it is just a vector component. Sinasabi lang niya kung ano yung component ng velocity. Para lang din siyang I at saka j. Okay? So, for example, dito sa may rectangular component, example natin, ang s is equal to 40i plus 2t squared j. So, kapag isusulat ko yung kanyang velocity, it is merely the derivative of your s with respect to time. So, kung kukunin ko ngayon yung velocity nito under sa rectangular components, that is equal to 4i plus 40j. Okay? Simply get the derivative of this. I'm not going back to differential equations. Dito naman sa may tangential and normal components, if this is the function of your s, to solve for your velocity, that is simply equal to the derivative of s with respect to t. And that is equal to, anong derivative nito? 10t. Right? So again, review your calculus. Moving. Pag naman sa acceleration, ano ang difference ng rectangular doon sa may tangential and normal component? Dito sa may rectangular components, we all know that pag sinabing acceleration, meron tayong acceleration along the x-axis, meron tayong acceleration along the y-axis. Again, do not be confused with the letters I and j. Those are just the components. For example, dito sa may rectangular component, give, ang kanyang velocity ay equal to ds over dt, that is equal to 4i plus 4tj. Now, kapag kukunin ko ngayon yung velocity, yung acceleration nito, kukunin ko lang yung derivative. Kasi nga, di ba, napag-aralan natin, acceleration is equal to the derivative of velocity with respect to time. So, kung kukunin ko yung derivative nitong v, that is what? Tama. That is 0i plus 4j. Ito yung acceleration given this velocity. Now, pagdating naman sa may tangential and normal components, ang sabi natin kanina, velocity is equal to ds over dtu or vu. Itong vt na to, I just want to clarify. Itong vt na to, this should be vt. This is your tangential velocity as I have discussed with you a while ago. So, kung kukunin ko yung derivative ngayon ng v, yun yung magiging acceleration. So, acceleration is equal to the derivative of your velocity, and from your calculus, applying your product rule, acceleration now is equal to dv over dtu plus du dt. Okay. Paano naging yung acceleration is equal to dv over dtu plus v du dt? Again, I applied here the product rule under your differential calculus. Anong sabi dun sa may product rule? So, if I'm going to get the derivative of this one, v is equal to vu. Diba, napag-aralan natin sa may differential calculus. Pag product rule, copy the first function, multiply it by the derivative of the second. The derivative of u is du over dt, plus copy the second term, multiply it by the derivative of the first term, that is dv over. Sa bali damot ko na yung padadalang. So, kita nyo ganun. So, again, itong equation na to, it came from your product rule, from your differential calculus. And, para makuha ko yung acceleration using this formula, alam ko yung velocity. Alam ko rin kung paano kunin yung dv over dt. Sabi ko, u is a component. But how can we solve for the derivative of u with respect to time? Paano siya? I just want to show you here, if this is the particle along the curve path, pansinin ninyo, kung yung particle nandyan sa point na yan, and it moves, di ba yung normal line, it passes through the center of curvature. Kung ililipat ko ngayon yung object dito, nagbago yung angle ng normal line, pati yung tangent line, tama? Yan. Habang lumilipat yung object, nagbabago yung angle ng normal line, tsaka yung tangent line. Ulitin natin. So, from here, the angle for the normal and tangent line changes. And sabi ko kanina, yung u, that is the vector component. So, it tells us kung asan yung component ng ating vector. And since, dito sa diagram na to, as the object moves, the vector component also moves. It changes. The angle changes. So, with that, I can say that du over dt is the change of the angle with respect to time. Ang hirap mag-solve ng angle. Kung babalikan natin to, paano natin isosolve yung angle nito? Right? So, there's another equation we can use to get the angle. Dito na papasok ngayon yung tinatawag nating arc length. So, for this diagram, you can see here there in your board. Yung S, that is the length of your arc. Yung letter R, that is the radius of your curvature. And theta, yan yung angle. So, from this diagram, you can derive here kung ano yung d theta over dt. And we have learned in geometry that for the length of the arc, that is equal to the radius multiplied by your angle. So, multiplied by your angle. Now, if we try to take the derivative of your s with respect to time, that is simply kinuha ko yung derivative dito sa may left side, kunin ko rin yung derivative sa my right side. Since r is a constant, ilalabas ko lang siya. So, I take the derivative of theta with respect to time. And I know that ds over dt is velocity. That is equal now to r multiplied by d theta over dt. And, kung ang gusto ko lang dito ay ito. So, iiwan ko ngayon dito yung d theta over dt, that is v over r, that is equal to d theta over. Fine. Sabi ko kanina, yung d theta over dt, that is equal to du over dt. So, with that, v over r is equal to du over dt. Yan ngayon. And, diba dun sa may I'm just showing you paano na-derive yung mga equations. I did not discuss this during yung mga pumunta dito last Monday. So, acceleration, sabi natin kanina, is equal to dv over dtu plus v du over dt. So, if I'm going to substitute the values here, dv over dtu plus v, our du over dt is v over r. Now, you have to take note again, itong v na to, that is the velocity, itong r, that is the radius of curvature. And, yung ating tangential acceleration, that is your dv over dtu. Yung ating normal acceleration, that is your v times v over r, or simply that is v squared over r. And from this, I can say that acceleration is equal to your tangential acceleration plus normal acceleration. Now, you have to take note, this is the Cartesian vector. So, if you're going to use this equation, this is in naka-Cartesian vector form yung ating acceleration. But, if we want to get yung acceleration natin is constant, we can use a is equal to the square root of at squared plus am squared. This is the resultant for your, this is the acceleration for your resultant form. Most of the problems we are going to encounter in this topic, we're going to use this one. So, pinakita ko lang po kung paano paano tayo nag-arrive sa final equation na ito. Just showed you the derivation. So, as a summary, here in the tangential and normal components, we have learned, just like the rectangular component, v is equal to ds over dt with the vector component u. And again, the velocity under this tangential and normal components is simply equal to your tangential velocity. As for your acceleration, always that is dv over dt u plus v squared over r. Okay? And take note that at is equal to dv over dtu, and your normal acceleration is equal to v squared over r. For the resultant form of your acceleration, that is equal to the square root of tangential acceleration plus square of normal acceleration. These are the equations we have to remember here in the tangential and normal components for the curvilinear motion of a particle. So, bago pala makalimutan. 80, this tells the magnitude of the acceleration. And itong En naman, this tells us how fast the acceleration changes direction. So, yung ating tangential acceleration, that is the magnitude of your acceleration, yun namang normal acceleration, it tells us kung ano yung direction ng ating acceleration. Okay, so we kindly take note of the definitions of our tangential acceleration and normal acceleration. To further understand itong mga formulas na ginagamit natin for tangential and normal components, let's have some examples. So, determine the acceleration of the particle moving in a circular path as shown below. At the instant that its velocity is 1 meter per second, while its tangential acceleration is 2 meter per second squared. So, to solve for this one, determine ano ba yung mga given sa problem na ito. So, for this, what are the given for this problem? Meron tayong velocity na 1 meter per second. Again, read the problem carefully. Tangential acceleration, so 80 is equal to 2 meters per second squared. And we are looking for the acceleration. Now, how can we solve for this acceleration? Sabi natin kanina, since yung mga given ay constant, we're going to use for the acceleration, that is equal to 80 squared plus an squared. Now, for this problem, given yung ating tangential acceleration, which is equal to 2. Ang an hindi given, but we know that normal acceleration is equal to v squared over r. Ang ating velocity ay given, that is 1 meter per second squared over r. Itong r na to, that is the radius of curvature. Now, if we try to look back dito sa may given, kung ito yung ating Earth, ito yung particle, it is moving along a circular path, and from here, kung ito yung center, yung radius from the particle hanggang dito sa may center of gravity, ay center of curvature, that is 1 meter. So, given yung ating r. So, directly substitute lang siya dito. And, makukuha natin yung ating normal acceleration, which is equal to 1. What is my unit? Again, if I'm going to expound this, that is 1 meter squared over second squared over 1 meter. Magka-cancel out yung meter sa baba, tsaka yung 1 meter dito. So, ang matitirang unit na lang is meter per second squared. That is the normal acceleration. Again, ang tinatanong dito sa problem na to is the acceleration. So, to finally solve for the requirement, that is equal to the square root of my 80 is 2 meter per second squared. Again, that is squared, plus 1 meter per second squared, that is squared. You try to input this in your calculator. This is equal to 2.24 meter per second squared. Ito ngayon yung hinahanap na acceleration sa problem. Again, kindly double check all the values I am inputting here. Baka may mali ako sa pinindot ko. Kindly press also enter these values in your calculator and double check my answer. So my acceleration is equal to 2.24 meter per second squared. For this problem, determine the velocity of the particle at the instant it reached point B. If its tangential acceleration is for s meter per second squared, while its normal acceleration is 0.48 s meter per second squared. The particle was at rest from the beginning. Use the figure for other information. Okay, so, given yung figure dito, wala pong given na radius. But the distance from point A to point B is given, 0.8. Ang hinahanap sa problem na to is the velocity. Anong gagamitin natin to solve for the velocity? Ang given dito is the tangential acceleration. So, these are the given. Sulat ko na lang. The tangential acceleration for s meter per second squared and an, that is 0.48 s meter per second squared. Okay. Dalawang acceleration ang given. Pero alin dyan ang gagamitin ko? Diba sabi nga natin, parang dun rin lang sa may rectangular component, we can analyze separately the x component and the y component. The same with this one. We can separate tangential acceleration and normal acceleration. So, kung ito ang gagamitin ko, tangential acceleration, I know that the equation for this is dv over dt u. For the normal acceleration, I know that the equation is v squared over r. Alin dito ang pwede kong gamitin? I cannot use an. Bakit? Walang given na radius. So, kung ito ang gagamitin ko, how can I relate acceleration and velocity? Now, dun sa may rectangular component, I have discussed with you, ADS is equal to V dV. Saan ko nakuha to? Kindly go back to our discussion on rectangular components. Now, sabi natin, I cannot use normal acceleration, so I'm going to use tangential acceleration. If I'm going to get the integral of both sides, may makukuha akong a value for the velocity. So, if I'm going to take the integral, my tangential acceleration is 4s ds, that is equal to the integral of v dv. Now, what would be my limits? Now, dito sa may problem, ang sabi dito, the particle was at rest from the beginning. So, initially, 0 yung ating position. So, ang ating lower limit ay 0. For dito sa may upper limit natin for ds, the distance traveled of the particle from point A to point B is 0.8. So, that will be our upper limit. For v dv, our upper limit is v. The integral of 4s. What is the integral of 4s? I-diretso ko na siya. The integral of 4s is 2s squared. Again, our limit is from 0 to 0.8. Integral of v. That is v squared over 2. Again, our limit is 0 to v. Lagi siya nakalipat di integral na, subliyan nyo di integral calculus. So, let's substitute our limits dun sa ating equation. That is 2. 0.8 minus 0 squared is equal to v minus 0 squared over 2. So, with that, what is the value of our v? That is times 0.8 squared times 2. That is, so our v now is equal to 1.6 meters per second. Ito nga yun, yung velocity na hinahanap sa problem na to. Okay? Third example. A race car drives a circular track as shown with its velocity expressed as vt cubed plus 8, where v is in meter per second while t is in while t is in seconds determines acceleration when it is equal to when t is equal to 2 seconds. Given po yung radius ng ating circle, that is 4 meters. Na ang hinahanap dito is the acceleration. Acceleration ang hinahanap. And since we need a constant value for acceleration, we're going to use the square root of at squared plus an squared. So, I need the value of my tangential acceleration and normal acceleration. I know that my tangential acceleration is equal to the derivative of v with respect to t. Again, yung u dito, that is the vector component. My an is equal to v squared over r. Saan ko kukunin yung derivative ng v with respect to t? Now, given dito sa problem na to, that the velocity is equal to 5t cubed plus 8. So, makukuha ko yung tangential acceleration, basta alam ko yung derivative ng 5t cubed plus 8. So, what is the derivative of 5t cubed plus 8? Yes, that is equal to 15t squared. Given naman yung time At t equal to 2 seconds, our tangential acceleration is equal to 15 times 2 squared. So, our tangential acceleration is equal to 60 meters per second squared. Ay, nakuha na ko na yung tangential acceleration. I need my normal acceleration. Saan ko kukunin si v? Since yung ating v ay 5t cubed plus 8, we can directly substitute for the v, that is equal to 5t cubed plus 8. Now, you have to take note that t is equal to 2 seconds. So, kapag isa-substitute ko lang siya, 5 times 2 cubed plus 8, that is equal to 48 meters per second. Right? So, masolve ko na ngayon si an, that is equal to 48 meters per second. This is raised to 2. Divide it by the r. R here is the radius of the circle, 4 meters. Therefore, our normal acceleration is equal now to, again, magka-cancel out yung meter sa baba at yung isang meter sa taas. Ang magiging unit ko ngayon is meter per second squared. 48 squared over 4 is equal to 576. That is meter per second squared. Again, this is not yet the final answer kasi ang hinahanap dito is the acceleration. So, I have to write the final answer. My acceleration now is equal to the square root of 80. That is 60 squared plus an squared, 576 squared. My acceleration now is equal to 579.12 meter per second squared. This is now my final answer for this problem. The box is traveling from point A to point B in a parabolic path. Its inertial acceleration is expressed as at is equal to 5t squared minus 16 meter per second squared. What is its velocity at any given time? Assume that the particle was initially at rest. What is its resultant acceleration if it took the particle 4 seconds to reach point B? So, for this given problem, let's solve first for letter A. So, sa letter A, ang hinahanap dito is the velocity. Again, ang sabi sa problem is at any given time. So, it is expected na yung ating answer in this problem for letter A ay hindi siya constant in terms of t siya. And initially, the particle was at rest. So, ano ba yung mga given dito? That's the tangential acceleration, 5t squared minus 16 meters per second squared. So, ito ang given. And we know that acceleration is equal to the derivative of v with respect to time. Since ang acceleration na given ay si tangential, we will use that one. Na kailangan ko dito si v. So, if I'm going to cross multiply, my dv here is equal to at dt. Now, paano ko makukuha yung velocity? I'm going to take the integral of both sides. From initially, our lower limit is 0 to v. And our time, or our um, limit natin for time, since ang hinahanap is at any given time, our upper limit is t. And we know that at is given as 5t squared minus 16. So that is the integral from 0 to b of dv. That is equal to the integral from 0 to t. Our at is 5t squared minus 16 dt. Integral of dv is v squared the integral of v is v and our limit is from 0 to v. That is equal to the integral of 5t squared. That is 5 over 3 of t cubed minus 16t. Again, our limit from 0 to t. Paano naging ganyan yung integral? Again, go back to your integral calculus. You have already discussed this during your integral calculus. So, makukuha ko yung final answer for v. That is equal to 5 over 3t cubed minus 16t. That is the final answer. Baka may magtanong ulit, bakit wala yung plus c? Diba sa integral calculus kasi natin, we always put plus c. Now, again, itong problem na to, this is an example of definite integral, so we don't need to add a constant c. Okay? So, that is the answer for letter A. Let's solve for letter B. Ilipat ko lang. Kopyahin ko lang muna yung figure. Okay. So, for letter B, ang sabi sa letter B, what is its resultant acceleration? Again, resultant acceleration ang hinahanap. So, we're going to use at squared plus an squared. And our time here is 4 seconds. So, makukuha ko yung acceleration. Basta alam ko yung tangential at saka yung normal acceleration. Also, first, for the tangential acceleration, that is equal to the derivative of v with respect to t, u. So, kunin ko lang yung derivative ng velocity. Kanina, na-solve natin that velocity at any time is equal to 5 over 3 t cubed minus 16t. Ito ngayon yung gagamitin ko para makuha ko si tangential acceleration. So, what is the derivative of 5 over 3 t cubed minus 16t? What is the derivative of this? That is simply equal to 5 over 3 of t squared minus 16. So, may tangential acceleration now. And given yung time, that is 4 seconds. So, substitute lang natin yung 4 seconds dito sa may value ng t. So, ang ating tangential acceleration is equal to 5 over 3 of 4 seconds squared minus 16. My tangential acceleration now is equal to 5, 3 times 4 squared minus 16, 10.67. This is meter per second squared. That is my tangential acceleration. Now, for my normal acceleration, we know that normal acceleration is equal to v squared over r. Wala akong problema sa v kasi alam ko na to eh. That v is equal to 5 over 3 t cubed minus 16t. So, isubstitute ko lang yung 4 seconds. Nagiging 5 over 3 times 4 cubed minus 16 times 4. My velocity here is equal to 5 3 times 4 cubed minus 16 times 4. My velocity is equal to 42.67 meters per second. Ay, alam ko yung V, pero paano yung R? Saan ko kukunin yung R? Again, R, that is the radius of your curvature. Itong dito kasi sa given na problem, this is not a circle, but rather this is a parabola. Given yung equation ng parabola, 16y is equal to x squared. And you have learned from your calculus, for the radius of curvature, any curve, the radius of it is equal to 1 plus y prime squared. This is raised to 3 halves over y double prime. Saan ko nakuha ito? Galing po siya sa may calculus. I'm not going to further discuss this because you have already discussed this during your calculus. If not, you may type there. Tanungin nyo na lang si Mr. Google paano nakuha si R. Ilitin natin. The radius of curvature for any curve is equal to 1 plus y prime squared. This is raised to 3 halves over y double prime. So, ano yung y prime? Ano yung y double prime? You have learned that y prime is the first derivative, y double prime is the second derivative. Given yung equation ng ating parabola, given yung equation ng parabola is 16y is equal to x squared. That is 16y is equal to x squared. So, pag kukunin ko si y, that is equal to x squared over 16. Now, the first derivative of this, the first derivative of x squared over 16, since constant, yung 1 over 16, ilalabas ko siya. Derivative of x squared is 2x, right? So, magiging 1 over 8x. The second derivative of 1 over 8x, ilalabas ko lang si 1 over 8. Derivative of x is 1. So, hindi ko na siya isusulat. So, ang ating so, ito ang ating y prime at saka y double prime. Now, dito, balikan natin yung figure. Given yung coordinates at point B, that is negative 2, 2. So, yun yung gagamitin ko. For y prime, ang x natin sa point B is negative 2. So, that is 1 over 8 times negative 2. This is equal to negative 2, negative 1/4. For my y double prime, it remains as 1 over 8. So, isa-substitute ko ngayon yung y prime at y double prime dito sa my r. Ang lalabas ngayon ng sagot ko, 1 plus my y prime is negative 1/4. That is squared. The whole of this is raised to 3 halves over y double prime is 1 over 8. And if you enter this in your calculator, this is equal to 8.76. Ano ang magiging unit ko? Babalikan ko yung given. Yung unit for acceleration is meter per second squared. Yung unit, therefore, from that, ang unit ko for radius is meters. Hindi pa yan yung final answer. I need to solve for my normal acceleration that is equal to v squared over r. Nasolve na natin kanina that v is equal to 42.67. So, direct substitution lang. 42.67 meters per second. Again, the whole of this is raised to 2 over My R, that is 8.76. So my normal acceleration is equal to 42.67 squared divided by 8.76. 207.85 meter per second squared. Again, nasolve natin kanina yung 80, that is 10.67. So if I'm going to solve now for my A, that is equal to the square root of 10.67 squared plus 207.85 squared. My acceleration is equal to 10.67 squared plus 207.85 squared. My answer here is 208.12 meter per second squared. This is now my final answer.